All right, so when you do polymerize ethylene, the name of that polymer is polyethylene. And you'll see these polymer names. Typically, poly is first, and then the name of the monomer unit is next, polyethylene. And you know that it's not really a polymer of ethylenes. There's not double bonds all the way down through there, but ethylene was the monomer unit, and you end up with single bonds. But anyway, some common products that are made from polyethylene are um, bubble wrap, and also like just plastic wrap that you would, wrap leftovers in. This is obviously a mustard container, a milk jug. Milk jugs are made of polyethylene, and this is a laundry detergent. Now, you may, and there's different things stamped on it and different dyes added to give the different colors and whatnot. But the products actually are quite different. Like, with a milk jug, it's pretty flexible, whereas with this, it's thicker. Bubble wrap is stretchy, and plastic wrap is even more stretchy. So if these are all products of polyethylene, they're all polyethylene, then there must be something going on differently, some other difference to give these different products. Here's an example of polyethylene. This is a spray and wash, and you can see it's a pretty hard plastic. And this is another example of polyethylene, and this is plastic wrap. Okay, and I know that this is made out of polyethylene because I double checked and I turned it over onto the bottom. Whoops, that's upside down. And I saw right there, it says under the number 2, the recycle symbol number 2, which we'll look at later in this unit, HDPE. That tells me what type of plastic this is. HDPE stands for high density polyethylene, whereas this plastic wrap is low density polyethylene. So there's something different about these two polyethylenes to give these different products, okay? So for example, like if I try to stretch this, I can't stretch it. It's so rigid. But if I take this little piece of plastic, I can pull on it and I can stretch it, okay? And you can see there's a difference. And then when I stop stretching it, it's all stretched out here. See, when I stop pulling on it, okay, and you can see when I'm pulling on this, I'm literally sliding and pulling the polymers past one another. All right, so what's going on here between HDPE and the other polyethylene in the plastic wrap is low density polyethylene, and it's abbreviated LDPE. Okay, so we have HDPE and LDPE. Well, the difference is that basically the amount of initiator that's added and the way in which the ethylene monomers are brought together. This process is more controlled, and we end up with largely straight chain polymer units, whereas in the LDPE, it's still all saturated hydrocarbons, but we end up with branching off the straight chain, okay? And what happens is with the straight chain, those long polymers can pack together more tightly, and then within the low density polyethylene situation, because of all the branching, the polymer units can't get quite as close together. All right, and since these molecules are all just saturated hydrocarbons, there's no polar ends, there's no dipole moment. The only type of forces that are holding these units together are dispersion forces. So dispersion forces are very, very dependent on distance. And so since these high-density polyethylene molecules, they're very, very large, can pack together very, very closely, then you have a lot of opportunity for the dispersion forces, and they become very, very strong. They're very, very tight. So the polymers, although they're not individually chemically combined, they are held together so tight one next to the other because they're huge, and they have all these dispersion forces. Whereas with the low density polyethylene, because of all the branching off here, they can't get as close together, so that the individual polymer units are not held as tight together because, again, the dispersion forces are very, very distance dependent. And so this polymer unit is far away from this polymer molecule, or polymer chain, I should say, is far away from this polymer chain, and so the forces holding them together aren't quite as tight. That's why I can literally pull on this polymer, because what I'm doing is I'm pulling the polymer, sliding them past each other. Eventually it will break. You'll just pull it such that the polymers are pulling away from each other, and you can literally break it. So that's pretty cool. So anyway, the difference, the subtle differences, this is why we say that you engineer polymers. You want particular properties. If plastic wrap were high density, it wouldn't work. So for the same cheap ingredients, just changing the chemical reaction, the temperature a little bit, and the amount of initiator a little bit, you can get vastly different properties. So again, that's an example of structure-function relationship, where the structure of the molecule changes and it gives me a different functionality, a different usefulness of that particular polymer. So if you want to can take a look at a model again from this this website. If this link doesn't work exactly, you can just go to this website and look for polyethylene, and you can take a look at the polymer and see how the long chains, polymer chains, just kind of entangle one another, and because they're so close together, they're held tight together in this very, very rigid solid. Okay, there's another type of polymer I'll just mention to you. It's called cross-linked polyethylene, and that particular polyethylene, there's been little chemical reactions that occur that actually cross-link and covalently combine, and these are even stronger. So whereas like the milk jugs are high-density polyethylene, typically the lids to the milk jugs are cross-linked polyethylene, because you can't even pull them apart or melt them, and they can withstand a lot of pressure and hold up under twisting on and twisting off and that sort of a thing. Okay.